Hi students, in this class we are going to see about rotor resistance starter that's used only for three-phase slip ring induction motor. Therefore, in question paper sometimes comes like this. Explain briefly the starter used only for three-phase slip ring induction motor. Then the answer is rotor resistance starter. All starter diagram is important. Therefore, draw the diagram according to my instructions. First, draw the stator side. Here I am using delta connections. We can use star connections also in stator side. So delta connections means all the windings are close together and form a delta format. Each corner you have to connect it through the separate phase R, Y, B. Rotor is the wound rotor or slip ring rotor. Wound rotor means the winding will be there. So draw the diagram as shown in blackboard. Center we having a shaft. Shaft is consist of three slip rings. Slip rings are made up of copper. The slip rings, each slip ring top also we having brush separately, bottom also we having brushes separately. Now the rotor diagram, rotor resistance diagram, starter diagram. You have to make a circle and you have to make a three set of resistance or rheostats. Starting terminals and ending terminals we have to mark for three set of rheostat, starting and ending. Then you have to mark 1 2 3 4 5 6 like that in a clockwise directions for all rheostat. Then you have to connect the rotor windings to the slip rings separately R, Y, B. Then with the help of brush, then output of that slip rings are goes to the rotor rheostat starter. Rotor rheostat starter. All the starting terminals are connected to the slip rings separately. The center we having a hub rotating switch now working. During the starting time we have to rotate the hub in anti-clockwise directions. Therefore maximum resistance in three phases it is added. During the starting time the slip value is 1. We all know during the starting time the slip value is 1, ns minus nr divided by ns. Therefore slip value is 1. So suddenly the resistance added means rotor current is increases. Then the stator full voltage is coming. Therefore current is in stator side is increases but rotor side current is reduces. Therefore starting torque is very high in particularly rotor resistance starter. For the applications of high starting torque, this rotor resistance starter is used. For example, lift, elevators, crane, etc. We are using slip ring induction motor. Why? Because means starting torque is high due to what? Rotor resistance starter. Resistance during the starting time, rotor resistance, external resistance is increases with the help of starter. External resistance increases means rotor current is decreases. Rotor current is decreases means stator current is also decreases. But stator voltage is normal. 430 voltage means 430 voltage goes to stator. Therefore starting torque is directly proportional to voltage square. So starting torque is very high in slip ring induction rotor. Now speed control in the sense we by varying the hub external resistance is decreases means current is increases in rotor. At the same time stator current is also increases, magnetic flux is increases, speed is increases. Rotor resistance increases means rotor current is decreases. At the same time stator current is also decreases. So stator magnetic flux is also decreases, rotor magnetic flux is decreases, speed is also goes to less. So here in this particular starter we having disadvantage. What's the disadvantage? Power losses is more. Therefore we are using power electronics speed controls in slip ring induction motors, slip power recovery schemes, Kramer's methods, Serbius methods, etc.